Yeah, hello, welcome to this session where we're going to basically talk about uh, trying to do a threat model of one of the tools that we've been developing. And it's also one of the things that I feel that it's really cool to do it kind of at something like the Open Security Summit, because this is an open source tool. So, the whole thing is already on GitHub, the whole thing is already published. So um, we can actually freely talk about it here. And because it's still in beta, it's a good opportunity to try to find the vulnerabilities or any kind of areas of concern before we kind of look at it. So what I was thinking of doing here is we actually have, I believe, some of the devs here that worked on this, and we got some members of the Glasswall security team also here, and I can throw in some questions if needed, right? And I think what we're going to do is just start with give you guys a quick intro on the tool, how everything works, how everything fits together, and then we can basically look at the sort of the architecture, how everything where possible areas, and there's a number of topics that I want to cover. And I think that the interesting thing for to see this is sometimes to see how even messy in the beginning the process is, right, for actually dealing with issues and threat models and all that jazz, right? So let me just quickly show the tool. So this is the tool. It's actually, you can actually download it from here. You can go to Glasswall desktop. It is available for Linux, OS X, and Windows. There's a couple of videos here that explain how it works. All the code is on GitHub. If you want interested in doing an Electron app or doing some React stuff, there's some pretty cool stuff on it. And fundamentally, what the tool does, it's kind of a local desktop interface to this tool that we developed a while back. So this is a tool that you can come in here, you can drop a file. For example, let's just drop a file that has some macros. There you go. So I can drop a file here, right? And this is basically our serverless sort of technology. So this is basically going to take a file, just waking up the serverless function, and then it looks at the file and going, hey, there's some macros on it, right? So, but basically, fundamentally, what our engine does is our engine will now recreate the file in a way that none of the other stuff is there, right? So if you saw before, there was macros, there was things, and now the new file doesn't have it, right? So just maybe another example, right? If I pick up the what's it called? Wait, give me a second. Where's that UI? Oh, sorry. Give me a second. I lost my files. Just getting them back in. Here we go. Cool. Right. Okay. So if I take, for example, this is another good example. If I take this PDF file that has JavaScript, so you could see it has some JavaScript on the PDF file, and it also has embedded files. So in this case, if the users say, hey, let me open up, then you can have, patient zero, kind of attack being launched, right? So clearly what we want is we want a PDF file that doesn't have none of this stuff. So what I can do is I can basically again pass them to the engine, and then the engine is going to basically analyze it, saying, yes, there was JavaScript, there was metadata. It also fixed things like, structures are wrong. This usually also can trigger buffer overflows and other things. And then, of course, if I download the file, the new file is not going to have JavaScript. It's not going to have, none of these things is going to be there. So again, you can see it. So this is kind of the workflow, right? So how to create safe files, how to create files that don't have these vulnerabilities, and then none of the JavaScript and stuff is there. So the Glasswall desktop is basically the same thing here. So you can actually invoke it from the cloud. Although what's cool is you can actually configure the server that it goes to. So you can actually configure the server that is actually doing the analysis. And actually, let me try this, because this is actually running through a different server. Let me try this actually. And so this first version runs through the cloud. There you go, right? So, and then this also gives you a nice cool file analysis. They say, hey, threat level high, blah, blah, blah. There was macros, there was metadata. And then, if you put in, for example, a different file, then that does the analysis, and that basically looks at the thing. So I think on this file, there's a bunch of metadata stuff. So again, different threads, different analysis, and different workflows. So this is basically going through the web, to the cloud version. And then what we got here, which is also, so the thread here, if you look at it from the architecture point of view, this is actually sending files to the web and downloading them, right? So we have a different version here, which actually allows us to do the same thing using Docker, right? So basically, this is different. So this is actually going to run local Docker containers. So if you look at my local Docker execution, right? What you basically see is that this one here, if I drop a bunch of different files, for example, if I drop multiple files in here, right? What you'll see is a bunch of Docker image being created. And now this is a very important concept here, right? Which you'll see in a bit, is that we are using one Docker container per file, right? And that's very important because potentially these files are malicious, right? So, we don't trust them, right? So we don't trust these files. So it's very important that, we have a huge amount of level of isolation on the files that we processed. Just the thing I want to show you quickly here, you also get a lot of metadata being saved locally. Again, this is important from a security point of view. Let me actually just, do that again so I can find it. And then you can see here that for the files, there's some analysis files being saved. There's the clean one, there's the original, and there's the XML report, which is the one that you can see at the bottom. A good way just to see the engine working is if I now rebuild again both and do the analysis on both files, you get to see that one is thread high and the other one is thread sort of okay, because this file has been processed by the engine, so it's safe. This file is the original one that had the JavaScript. One of the things that you can do, which again, has some potential vulnerabilities. Actually, this is cool because you can actually see the watermark. Actually, let's say, hello world, and what I'm going to do here is I can actually, for example, change the policy to disallow. So this has some interesting side effects from a security point of view, because if you say allow, this will actually allow the particular code to actually be there. So this will remove, for example, the embedded image, but basically will still allow the JavaScript functionality to exist, which is probably something that we wouldn't want to see happening, right? So if I go there and double check it, and but you also have the watermark. See, so what you have here, you got
ein Reiter du, ein Reiter ich.
Hey, wait, sorry, can somebody mute? I think we need to mute somebody. All right. Yeah, so you can see in this case, the policy, which is actually technically very dangerous, right? So you can see that when we look at the threads, to be able to bypass the policy or modify it, technically in this case, we removed the, what's it called, the embedded files, we clean them, a bunch of things, and actually you can see that we watermark here, right? Which is basically just a nice way to test to make sure it's working. And of course, the final thing here is that you can see that, the file is very complex, but, it still is usable. It looks less like the real thing, but, it has been through the engine. So in this case, the policy could actually cause problems, right? Because, you can, create a policy that actually bring to a secure state. So here's where you can access all the rebuild status. You get some health check, which is pretty cool. And then you got the raw logs, which again, from a security point of view, they shouldn't have sensitive data, but you could have. And then here you actually got the API server that we're using, the API key that we're using, and then the actual version of the Docker key that is being distributed. By the way, Petra and others, if you're here, this is actually one of the ICAP servers, which is pretty cool. So it's actually running off that. So cool. So that's the functionality of the app. Let's now just quickly go through this introduction here. So yeah, so you basically see that there's multiple files we can do: policy management, XML reports, threat intelligence, the sessions, the health check, logging, cloud, and Docker configuration. there's the UI, so you can put the policy, you can configure, you can drag and drop files. These are all the features, right, that you've got, right? Then, so this is sort of, where, start to look at the process to make sure Docker is installed. So this is the health check we were talking about. So we do now a check. And the other thing that you can see here is that even from a security point of view, we are invoking Docker, right? So we actually are starting processes in the machine, right? Which, has some interesting security implications. There's some cool features. You can also do the health check, sequential execution, etc. And then, there's the health check, the rebuild for Docker, and there's those options running it in parallel and hierarchy. Another potential issue that we can look in also is that when you're running sequential, there's not a lot of implication for your local machine. But if you're doing parallel, this was literally start Docker instances, Docker containers per file. So you can easily drop a folder that has 100 files, and you're going to see 100 Docker images starting. There's the policy. You can change the policy based on what you want, which is what you've seen there. And you can see that there's a policy for Word, for Excel, for config, and that's the kind of stuff that we can, move out or decide to manipulate. And then the file analysis is very crude at the moment, but it already applies to the files that we do and allows you to kind of see the stuff that's, so actually this file analysis is actually what the engine does, which is actually very thorough. And then this is the example report that you get. One of the assumptions that we're making here when we talk about data, and we already done this on the ICAP product, was to basically say that there should be no sensitive data in here. So, this is the analysis of the threads. This is the kind of some of the attributes that we calculate, and you can see that there's also the file type, and then the original and the rebuild. Sometimes these don't match, which is an example of something dodgy that could happen. The threat levels, and then the stuff that we actually removed, the stuff that we repaired, and then all the sessions that got stored, and the config. I show you this, the logging, and there you go. Cool. And then, if you have an issue, please report it, right, on there. So the architecture very quickly is you got the Glasswall, desktop, you can hit the Glasswall cloud or a server for analysis. You put data files, insecure files here, can also run Docker, and then saves the clean files and the dirty files in the local system, and is given a policy in, right? So that's the whirlwind of the tool. Any questions so far?
Probably we'll have when we get to the data flow diagram.
Yeah. Oh. So let's just quickly, so let's now look at, the thread modeling of this, right? So Petra, do you want to take the lead a little bit on this one?
Well, we need to do a data flow diagram, isn't it? Or are we not going to do one live?
Yeah, we can do, yeah.
Do you have a tool that you had in mind, Dinis?
I could probably use here. I can do it here quickly.
Okay. All right. Let's do one here.
So
we have a user.
Yep. Well, the user's here, right?
Yeah.
I'm going to do this guy because this guy already has the bits that are needed. So I probably should go to list it chart, but since I'm here, I might as well do it. All right, user. Yep.
And then it's connecting to the Glasswall desktop, which is how is it authenticated? Is it HTTPS to Glasswall desktop?
So the Glasswall desktop, I'll do it here, right? So the Glasswall desktop is an Electron app, right?
Right.
So it's actually interesting because if you look at the Glasswall desktop, just to throw some curveballs on it, right? This thing is actually running Chrome inside of it. So one of the biggest things from a security point of view that we need to look at, right, is the fact that inside the Glasswall desktop, right, what you actually have is is these things here, right? So if I change the colors of this, what you actually have is you actually have Chrome and you have Node.js,
Right.
right? And what they do is they share the same event loop. So what this means, it means that you can actually code web, you basically can be coding on a web page, right? And you can invoke commands on the OS. Does that make sense?
Yeah.
See how dangerous that is?
So if it's a,
Sorry, Dinis, forgive me. Does that mean there's no logical separation between the two?
Nope.
Ooh.
But by the way, you know, just wait,
Ooh.
so that you see them, you know, that you know, we're not going insane on what we're doing here, right? This is literally how what's it called? You know, you've probably used this before: Visual Studio Code, Messenger, Microsoft Teams, Slack. They're all using Electron, right?
That's interesting. I suspect the West Country will have a field day with that.
Yeah. So yeah. So basically, what you have is an electron. So if electron is this bit here, right? You know, the way it works, and the reason why electron is so successful, right, is because of this, right? Literally, this is the big USP of electron, right? Is literally that it is running Chrome, right, which is basically the web browser rendering, and Node.js in the same sort of you know, nodes
Same
kind of.
session.
Actually, what's it called? What's the Node.js engine? Runtime. What's it called? Chrome V8. That's it. Yeah. So and this happened because you know, Node.js was built on top of the Chrome V8 engine, which is the one here, right? So you got the same. So you got the same JavaScript event loop, right? Which actually means you can block the UI from the back end, and this is running on Chrome V8 engine.
so I presume the user is using HTTPS to connect to it then.
Kind of, not really. So the user in this case is, so if you look at now the desktop of the user, right? So what you've got is this is now, and this is actually a problem, right? Because if you look at this, right? This guy here is the desktop of the user. So let's say this is the environment of the user, right?
Right.
And that means that this is running in the same process space that everything else, right? So for example, to put this into perspective, right? What you've got here, right, is that if you look at the user space environment as this guy here, everything that is running in that process space, you'll be able to access from the Electron app, right? So what it means that if this is the user's, you know, user process, or I call it desktop, right, for now, but it's literally the user process, right? Actually, user, what should we call it? Yeah, user account, right? User environment. So this is the user account, right? Every process that you have running here, you can access from Electron, right? So, which is actually, you know, shows the, you know, the level of trust you have to have, right, on these apps, right?
So the user is basically in the same trust boundary as the app.
Yep.
The possibly a different way of stating the same thing is all the processes that the user is running are running as the same account as in them.
Yeah, correct.
Right. Okay.
Yep. So what it means, yeah, so if you look at this, right, what you've got is a situation where, you know, if I now have a couple of more apps here, right, that are running in the same process, right, and you can see, like, the reason why the Docker bit works is because it can talk to Docker, right? But this could be, could be Chrome, right? Could be your main Chrome. All of these apps will be available for the user, right? Right.
As
So
does Electron support any of the mobile platforms, so iOS or Android?
no.
Okay, I haven't looked.
Because of this, right? Because the whole point of Electron, right, is that what you then do, right, is you write React. So in our case, we have a React.js app, right?
Yeah.
But if you look at, for example, the workflow for, how does the code get executed, right? So if you now look at the user account is here, and going back to your question, Petra. So how does the user interact with this? Well, the user basically is moving the mouse, right? So if you look at it from a user point of view, the user, if it's here, is literally just using the mouse to interact with the UI here.
Okay.
So this is just mouse movements and clicks and enter, right?
Okay.
Which is kind of what you saw, mouse and keyboard, right? So that's literally how the user interacts with the thing, right? Which is kind of what you see, there, right? So if you look here, I'm interacting with a web page, right? So I didn't open any of these web pages. So this is basically the UI that's been opened in Electron here.
Right.
Which is a web page, but it's not served locally. So there's no local web server.
Okay.
There's actually, so if you actually look at, so you can actually see it here, because if you go into the Docker, if you look at the target directory, no, not this one. Once you see an execution, if you look at the actual output folder, right, you can actually see it working here, right? So if you look in here, this is all the files that exist, right? So what you've got here is basically almost a local version of Chrome. This is what your Chrome looks like, right? Your environment. In fact,
Okay.
no, this is the temp files, right? If you then go into the application here, you then see the actual source code of it, right? And in here, one of these guys, I haven't looked in for a while, would actually be the actual codes that, so in here, there would actually be the pages that we're actually opening up, right?
Okay.
Then,
So we can ask the questions about authentication and all that later, once we kind of get a grasp of the architecture. So if we want to use the app, we drop a file. So does it call the rebuild API? Does it communicate with the?
There's these two modes of operation, right? There's one mode where it calls a cloud server,
right?
Right, and there's the other mode that uses the Docker local Docker instance.
Okay. And so how does it communicate with the cloud server? So we have on the server, we have our probably like a request processing server, which will contain our core engine, the SDK.
Yep.
And how does it communicate with the SDK?
It yeah, so that's now that will depend on the on the endpoint, but yes, in this case is it will be over SSL. So actually it will be whatever is configured here. So in this case, yeah, so in this case it's actually going over SSL.
Okay, and it communicates directly to or does it have any services in between?
No, it calls directly to this endpoint. So these are the two URLs that will be hit by the.
Okay.
So basically, yeah. So the user sends the thing to the Glasswall desktop, right? and
Yeah.
you know, and then that will use, well, we'll use, it depends if it's configured, right? It could not use SSL, but at the moment I don't think there's any check to see if it's non-SSL, which actually would be a cool addition, because we probably should say, that's actually a good example of a feature that we should add to the product, which is don't allow the user to put HTTP on it. Right. In fact, Mudit, since you're on a call, can you capture this feature request? And Jonathan, I think you guys are here too, right? So yeah, so we should add a feature to prevent the user from putting HTTP in there. So we should enforce HTTPS there, which I don't believe at the moment we do.
And there is
Okay.
no what authentication? Just use the API key to authenticate with.
Yeah.
Okay.
So actually, it's actually interesting, right? Yeah. So yeah. So basically, you could see, yes. So this goes HTTPS plus API key. Yeah. So you can see that the API key is sent here, which actually now gives you a problem, right? Well, not a problem, but when we look at, which we need in a bit, look at the assets, right? So if you look at the assets stored locally, one of them is this API key.
Sorry, Dinis, I think I joined a little bit late. Did you demo how the Glasswall desktop works? Did we do this?
Yeah.
Okay, cool.
So
one of the challenges here that we have, we can already say, is how to give how to give the key to the user. And this is a good example at the moment. The API key, the VON, right, is that it's hard coded in the app. So in this version, and this is actually, for the guys on the call, right? This is something that I'm very passionate about, which is the idea that you want to know as soon as possible what are the vulnerabilities that exist on the application, right? So it doesn't matter how soon you go, you have a number of vulnerabilities which are okay, right? It's okay to have vulnerabilities in the app, right? Especially when it's beta, because there's still time to fix. In fact, the worst place to find vulnerabilities is at the end, right? So, we shouldn't shy away from identifying the vulnerabilities, from identifying, the high, medium risks you have, right? Because, the more we know about this, right, the better it is, right? So in this case, the keys are actually hard-coded in a version, and this is the same key as used in the file drop. And me and Petra had a very interesting set of conversations recently, which was about, if you look at the file drop here, when you use this engine, basically this will already send the key to the server, right? So if you look here, the key is included in a request because it has to, or else you can't talk to the server, right? So it's a good example of, we cannot protect this key. At least we could rotate it very effectively, or we can maybe try to hide it in backend, but even then it would be almost the equivalent. But this key only gives you access to call the API. So basically, even if we put a service behind it, it will be the same thing as having a key exposed, right? Because the interesting thing here is that we can maybe try to protect a little bit by understanding where it came from and what are the workflows. But this is a good example of a key that, because we decide to make this service publicly, the key has to be exposed, right? It's almost by design.
Yeah.
Yep. Allows. So the VON here is allows non SSL traffic or TLS. Cool. All right. So yes, you got the user hit the desktop. So this is, fundamentally here is he uses, the mouse and keyboard. Then the Glasswall desktop sends the thing. So now if you look at, so one thing that's important also from a security point of view, and you look at the assets, right, that I was mapping here, right? So this is actually assets. And then actually I should break this into VONs. VONs, cool. One of the assets we have is actually the file that was given from the user, right? Because this is now, if you look at it, what you now have is this file, and I'm going to put it here on red because technically maybe, let's assume that it's insecure for now, right? So what I got is, I got the file here, which is the, the dangerous file. So this is the, the original file. The file is given, is basically drag and drop to the desktop. So it goes into the desktop, memory space, and then is sent to the Glasswall API, but also is stored.
Yeah, is it stored?
In the local storage, right?
Oh, there's a local storage. Okay.
Well, a local disk, right? Sorry.
Does it, is this storage encrypted?
Nope.
That's what I want to ask. Okay. Thanks, Ben.
And does the file get deleted after it's rebuilt, or does it stay in the local store?
At the moment it stays in local storage.
And how is the API stored locally? I mean, still like
The API, yeah, the API doesn't store anything. At the moment, this server deletes it.
okay.
So yeah, so you get the clean version, and also you get the clean version sent to you here.
So there, we have like a rebuilt, kind of like a original and rebuilt storage inside the desktop.
Yes, which is this, right? So if I show you this, see that this folder here?
Mm-hmm.
This folder contains,
Right.
this is that folder, right? So this is the file, the data that is stored per file.
How is the, so the one who is in the original store, if it stays in the originals, I mean the file that gets dropped in, the original file, how do we sandbox it? Like once it's inside the storage, so it doesn't. How do we divide it, make it into a separate trust boundary? Because we don't trust that file, obviously.
Yeah, it's kind of, you totally read my mind.
Okay.
It's scary. I was literally about to say that this file here is
right.
not encrypted, right? Like you said. What's it called? But also not even zipped. And because, so the best practice, at least, it should be zipped, right? Because the problem is, right, is, if you assume that this file is malicious, right, what happens if the user accidentally click on it?
Yeah.
Right, so it's actually very dangerous, because we went to a place where the user, well, okay, the user could have clicked on the original one, but that maybe, that's probably less likely, where this guy here, right, the problem is what happens if the user clicks on it.
Yeah.
So I think that's quite, it's an interesting situation, because, technically not this one, sorry, that one, right? Right? User clicks on it, because this is basically, this file could be potential malicious, right?
Yeah. And basically, if it's not sandbox, if it's not isolated from the environment, it will infect the whole system.
Well, no, unless you click on it, right?
Yeah, yeah.
And Dinis, when this was built, did you take into consideration the Electron best security practices? I was looking that up. It looks like there are a lot of things that needs to be handled, changed manually. So did we do any of this?
I think we did some, but it's definitely an area that we need to do a security review on it.
Okay.
But this is also where, like the power here, right, is to find the target, right? So one of the things that I would say is very obvious, right, when you look at the security of this, is that we need to look at the security of the Electron app, right? So if you look at the security targets, right, like the areas to focus on, right, the security review, and to do the more detailed threat model, right? And actually, remember, Petra, now is when we're talking about what's it called, nested threat models.
Yeah.
This is a good example where you need to start with this first, right? Because you need to understand what are the dangers that you get just by using the Electron application.
Yeah, and this also can attach itself to the core engine threat model, because
Yeah.
this goes on top of it.
Oh, exactly. Absolutely. Yeah. And actually, interesting, right? Is the core engine threat model actually the Glasswall core engine, but is the Docker version, right? Remember, that's different, right? Because this is a good example of the threat model here, right? When you look at the Docker version. So on this version, the file is never opened by the user, right? So the user gets the file never becomes active, right? Because the user is then given, this file here, right?
Yeah.
The user then gets given this file, but the idea is that the user should never click on the red one, right?
Yeah.
You just drags and drop it, right? And eventually we might get to the point where we'll just pick it up as soon as it's saved on the file or USB stick, right? But the interesting thing of the local version, right? If you look at the local version, right, there is 2 ways this could have worked, right? In fact, this is quite interesting because there is one way I can do it here, right? Where you could have the Glasswall engine running in process. Remember, this is the conversation we had in the other one, right? So you have 2 ways you could do this, right? You could do the Glasswall engine could be running inside the same process space, right? As
That's for the local version, you mean?
Yeah. So there's 2 modes, right? That you could have designed this. One of them is this version, right? Which is actually, I would say, very dangerous, right?
Yeah.
Because
we don't want that, no.
Yeah. And then there's the version that we have, which is basically this, where basically is actually Docker is running here, right? And then the Glasswall engine is running inside Docker.
And this is where we have every pod getting, per file.
Correct.
And that's how we stop the spread.
Yes. So
if there's anything that triggers.
Yeah. So that means that what you got here is basically, in essence, you have, in all practical reasons, what you've got is this.
Do we have like do we also have like a policy management service?
No, the policy is actually an XML file that is stored on disk. Yeah, so literally is an XML file that is stored on the inside. So the policy is basically stored in the file system
of where the app is running.
Yeah, correct.
In
fact, actually, it's a good thing because actually it's a good. Okay, let me just break that guy here. Yeah, so the policy is running inside the app or in the cloud version in the cloud thing. So there, yep. So and then the policy in this case is also sent to the users there, right? It's also sent to the Docker version, right? But on this version here, the policy actually exists here, right? It doesn't exist on the other one.
And we said that's protected with an HTTPS and an API key.
Which actually means that, for example, the local version, one of the vulnerabilities, you can manipulate the policy.
Yeah.
Right? Because
do we encrypt?
Sorry?
Do we encrypt the policy? You said it's an XML file. Can we encrypt? We don't encrypt it, right?
It actually means that one of the attacks is that, another app, right? So, what's an app you run on your computer? Angry Bird.
Yeah, calculator.
Right? So the calculator, right? Or a rogue app here, right?
Yeah.
A rogue app, it could, for example, attack the policy directly here, right?
So what we can do, we could potentially encrypt that, isn't it? Or we could also make it that only the desktop app can write to it?
That would be very difficult to do because these guys are all running on the same process.
Okay.
And
So what can we do?
This is where,
security gap, right?
sorry?
They all run in the same process. There's a big security gap.
No. So not the same process, the same user account. But
okay, so what if we need to? How do we handle like permission elevation and stuff like that? So
Yeah, privilege escalation. Yeah.
that's the problem, right? Well,
Yeah.
technically, it's not permission escalation because this is the same user, right?
okay, this user, when is it an admin? Okay.
No, but this is where now, you know, what's interesting about this is when you look at the design patterns, right? And this, you know, and this is something that, again, we should acknowledge this, right? Because there is, you know, the question here is where you're running on kernel versus userland, right? Because the way, the problem we have in security in the desktop, right, is that if you look at the computer, right, there's only two security boundaries in your local environment, right? There's a security environment between processes, and there's the security environment between between kernel and userland, right? So what you've got here is that, you know, in blue you got processes, right? And in, so this is two different processes running, right? This is, let's say, P1, this is P2, and this is user 1, right? Okay, and then, you know, this is user 2, right? So what you've got, you know, in the OS, you got basically the situation where you know, P1 has full access to P2, right?
Yeah.
So there's no way, at least in most OS, right, that you can prevent, you know, this attack, right? So a rogue process here, right, you know, has able to have full access to basically to P2 and any data that the user has under that account, right?
Yeah.
So any data, any files, anything that exists here, this guy is rogue, that he has access to all of it, right? So the interesting question when you look at this is, where do you run the analysis, right? So this is files. So the difference is that if this is the kernel, right? You know, of your environments, this is the reason why the AVs run here, right? Right, or at least they have access, they run with admin, right? So the AVs will run and they will have a kernel module, right, to do a lot of the heavy lifting for them. Because now you got an isolation, right? And now you can communicate between userland process, right? And for example, an admin process that actually, you know, is running, you know, userland, but is isolated from the rest, right? So at the moment, what we don't do is we run all our engines, we run the whole thing in the same process by design, except when you use Docker, right? When you do Docker, that's a little bit different. But Docker gives us a little bit of the isolation, right? That you do. So that's why when you use Docker, what is actually happening is, you know, because Docker is already configured as admin, right? We allow that to happen here. So the normal user won't have access. Well, actually, technically you would, because the user can tell Docker, right? So the user can, other process can still access, yeah, other rogue apps can still access Docker and still run stuff inside the process.
Yeah, that's what question Mel Juice had a question. What is the user context under which the Docker container runs on the host?
The user context, well, Docker runs a root, right? But you can interact with it from well, in normal environments, I think all processes can call Docker, in your normal desktop. I think depends how you install it in Linux. Sometimes you actually need to give it extra privileges to talk to the Docker container. But I think in at least when I install Docker desktop, I'm pretty sure that yeah they do, because I don't need to do sudo to execute Docker, right? So I can just go Docker ps, right? And I can invoke it. So if this was installed with different, I would have to do this. But in this case, I can just go Docker ps. So basically, that means that any app here can call the Docker. So it actually means that any app here can access the files either in the desktop here or in there. Although I believe that we delete the container after it's been executed. So there's only a very small window of opportunity to actually grab the file. Does that make sense? So if you look
Yes,
here,
it does. Yeah, I asked at the time when you were talking about potential for privilege escalation, because there certainly have been escapes from Docker, and as well as remote code exploits against Chromium. So if somebody could chain a couple of different exploits together, they could potentially break out of that container.
Yeah, correct. Yes. So basically, one of the blind spots here would actually be that, right? So well, not blind spots. So we rely on Docker. Basically, I'm just showing you so you can actually see the processes flying around. See, so it runs multiple processes in parallel. Actually, let me drop some more so you can see a bigger pile. Yeah, so basically you would depend on a Docker. Yeah, if there's an exploit, if somebody has something to jump out of Docker, then then they'll find themselves in the same place as the user, right? So you can see the multiple. So you can see that there's in this case a very small window of opportunity to grab this. To be able to jump into these processes. And I actually believe that even if you jump into it, it'd be good to double check, but if you jump into it, as soon as the master process is finished, you will be kicked out. And we actually delete the Docker when it's finished. But the problem you have here, and you need to think about the alternative, right? In this model here, right? If you pop out of the process, it's already game over, right? Here, if you're able to find, so you need to find first of all, you need to find a buffer overflow in the Glasswall API. So the Glasswall sort of engine, right? Which is, we don't know of any at the moment, but it could happen, right? So you need to first get code execution, and then depends where you are, depends how dangerous it is. If you are in the embed version, then you can basically have a situation where you're already in user land, which is why it's very dangerous to do that. If you're in the Docker, then it's different, right? Because so this is embedded, and then this is Docker version. But this is a good example of we should have. In fact, actually, Petra, like you're saying, right? If you look at the Glasswall core engine, that will explain us this decision. Mm-hmm. Why we chose to go for the Docker version versus the embedded version.
Yeah.
What about cross-site, like scripting on the embedded version?
So where cross-site scripting becomes very dangerous is here. If any of these guys has cross-site scripting, guess what context you're running under?
Oh.
Right? And I show you, and yeah. And Mudit, you're still on the call, right? Because the reason why, you see this is something that's very interesting, right? Because when you look at the thread model of the Electron app, right? Like the stuff that we get from the Electron app, one of the things that you have to look at is, is going to that list, right? That you were talking about, Abbas?
Yeah,
Right?
I'm just, it's too many things there, but apparently you can prevent most of them with some manual configuration. So
yeah, there's some stuff you have to make sure, right? So one of the things you have to be very careful is XSS can be lethal, right? On this, right? Because this will allow, right, code execution on the client, right? If you're not isolating, so we have to be very careful. Which we have to make sure that the windows are isolated, right? There's a way to sandbox it.
yes,
right?
I saw that.
And but we have to be careful because some of it don't fully work, right? The dangerous is here, right? The dangerous, right, is to open a window that allows navigation.
So they're saying the remedy is to define a content security policy.
Yeah, that's one of them. But I'll show you an example. Is this? See when I report an issue?
Yeah.
Can you see that I'm browsing this here?
Yeah.
Right? This dude here at the moment, right, is running under, where's the Electron context? That is running here.
Okay.
And has access to that.
And Node.js as well. Did we have like the best practices applied there as well?
Yeah. But Mundi, can you see the problem here?
Yeah.
Yes.
Basically, if I navigate now to a page that runs JavaScript on this page, controlled by an attacker, right? You will be able to now make calls to the local file system.
Correct.
Wow.
And read my AWS keys.
Right.
But the good news is ours has put 2FA in our AWS so that our keys only lasts, 10 minutes. And I get an alert from the Pendabot every time I do something. Which is really cool.
Scottybot, yeah.
Scottybot, sorry, not the Pendabot, Scottybot.
The Pendabot works on,
it's
Scottybot. It's our
yeah, so cool. So Mundi, one of the things I want to do is now you start to see how you want to think about the application, right? So what we need to do next time is have the next version of this. You just create a bunch of diagrams based on this. And then what we want to do is we want to ask the questions, which is basically, the stride questions, which is basically where we were going with this.
Yeah.
Yeah.
And basically, so what you want to do is you want to do these things, and then you have a first pass. Then Petra and the AppSec team and the security champions can review it, and then we just do a bunch of loops. So next month we do another one, and we can show them the evolution of this.
Mm-hmm.
But I think what I want to show is that, look, just going through this is actually really powerful, right? Because you start to understand, and what you're getting is you also start to understand what are the areas to focus on, right? So, the security team, when you guys are going to do a pen test on this or security review, it's very important to understand that you have to focus on the Electron, right? You have to focus on those areas, but also follow the files and know the biggest center of gravity from a security point of view that you need to look at.
Yeah.
So, cool. Any final questions?
How do we authenticate into the app as a user?
You don't.
It's free.
But the app, okay. Okay.
Well,
so interesting.
So here's the logic, right? So the logic here, this is where we need to talk about licensing, right? So the logic is running on the evaluation version. So the logic is, and actually this is a good example of the power of open source. So the plan here is to create a fork of the repo for specific customers, right? And then allow us to customize it. For example, add the logo to them, which is also going to be quite cool, but also hard code some of these, because the user or at least hard code the location where to download this, right? Because the user, when they run inside their own company, needs to have a way to get this information, right? So that's for the cloud version. And for the Docker version, now it depends on which version they're running, right? So then what we'll do is we'll sell the version that has the engine. So this has the evaluation version of it. But the logic of this app is that the user is already authenticated locally, right? So this is about the user processing their own files.
Mm-hmm.
So in a way, we don't need a lot of authentication because the user already authenticated.
Okay.
Cool. All right, there you go. So that wraps up this first session.